Therefore, product is also a complex number. Therefore, Z1, Z2, a complex number. We can easily verify that by taking n as 2 and 3. After calculating, we will see that the result will be a complex number. Now, I am in the position to discuss algebra of complex numbers. Algebra of complex numbers mean different operations and other things. First of all, sum difference of two complex numbers. Sum of two complex numbers is also another complex number. Difference of two complex numbers is also another complex number. Let me clarify. Two complex numbers are Z1 x1 plus iy1, Z2 x2 plus iy2. Therefore, if I take the sum Z1 plus Z2, that will be equal to x1 plus iy1, x2 plus iy2. x1, I take the real part together, that is why x1 plus x2, then the imaginary parts from which I can take I common factor. Therefore, which is of the form a plus I2. Therefore, Z1 plus Z2 is a complex number. Then I take the difference Z1 minus Z2. What will be that? It will be x1 minus x2 . This is also a complex number. Thus, sum of two complex numbers or difference of two complex numbers is also a complex number. Now, product. For that, I calculate Z1 into Z2. We multiply iy1 into iy2, that will give minus y1 y2, as there will be I square whose value is minus 1. Now I take the real part, and the imaginary part. Thus we find this is of the form therefore product is also a complex number. Therefore Z1, Z2 a complex number. Next, quotient. If we divide Z1 by Z2, we calculate first we convert the denominator into real by multiplying both numerator and denominator by x2 minus iy2, that is the conjugate of z2. I write that and if we multiply x2 plus iy2 by x2 minus iy2, after multiplication and putting I square equal to minus 1, it will be x2 square plus y2 square. Now I multiply the denominator and express that result in the a plus ib form. x1 into x2, that is real, then iy1 into minus iy2, the product will be minus I square y1 y2. Since minus I square equal to 1, therefore finally that will be y1 y2. Then I have taken imaginary part I into x2 y1 and from it minus I into x1 y2. Therefore finally this. Now if I express that in the form a plus ib, which is of the form a plus ib, therefore next if we raise to the power integral power, positive integral power or integral power, then that new complex number, that new number will also be a complex number. I call it 4. means x plus I y whole to the power n. That will be a complex number. We can easily verify that by taking n as 2 and 3. After calculating, we will see that the result will be a complex number. Let us take n equal to 2. I square y square means y square. That means z square equal to x square minus y square, real part, plus I into 2xy, imaginary part. That means a plus I be formed. A equal to here x square minus y square and b equal to 2xy. Therefore, if we raise power, integral power, then the new number will be a complex number. Similarly, we take z cube like this, and the general result is integral power of a complex number is also a complex number. Next one is if we take root of a complex number. That means square root, cube root, fourth root, etc. The newly formed number will also be a complex number. These are also called properties. I have discussed here under the heading algebra of complex numbers. These are also called properties of complex number, root of a complex number. In the next episode rather, I shall take sums of which we will extract square root, also in some cases cube root, and so that the newly formed number will be a complex number. Next, mode properties. Those are I take the caption mode properties. First of all, if the complex number or if a given complex number be 0, then its real part and imaginary parts both are 0. The given complex number is 0. We can easily prove that. First I take the imaginary part on the right side, squaring from that we get x square plus y square equal to 0. Sum of two squares is 0. we have learned in the lower class, if we get this, then the conclusion is both x0, y0. Actually, two square numbers are there and their sum is 0. This is possible if both the numbers be 0. Therefore, then number 2, two complex numbers are equal. That means z1 equal to z2. This will be possible if real parts of the complex numbers be equal and their imaginary parts be equal. Let me clarify that. I take real parts on the left side and on the right side squaring after few steps we have got sum of two squares equal to 0. Already I have discussed, if we get this, then the conclusion will be each of them from it we get x1 equal to x2 and from this we get y1 equal to y2. Therefore, z1 equal to z2. Therefore, if two complex numbers be equal, then their real parts will be equal, also their imaginary parts will be equal. In the next episode, I shall discuss the properties related to moduli of two complex numbers, amplitude of two complex numbers. Thank you.